Okay, this is the first recording for chapter 6.1, and it's properties of exponents, but what you're going to be working on today is simplifying and evaluating powers using the properties of exponents. So these will be expressions involving powers. So we have the product and quotient of powers property. So there's a bunch of powers, but I'm going to separate them out differently. If you want to look in your book, in chapter 6, you will see all of the powers in a big blue box on page 296. I've separated them out just a little bit differently. So the power of products, the product of powers property is when you have the same base. So when you have the same base, the base is, in this case, in product of powers is the A. In the numeric case, it's the 3. When you have the same base, some things will be very similar for product of powers and quotient of powers. So if you have a to the m times a to the n, you can see that the bases a are the same. You're going to get a to the m plus n, so you'll add the exponents. Now I'm not so worried about you memorizing that, but that you understand it. So for instance, here's a numeric example. 3 to the second times 3 to the third. Well, the bases 3 are the same. You have 2 3's, 1, 2, and then you have 3 3's, 1, 2, 3. Which if you look at this, 3 times 3 times 3 times 3 times 3 is the same as 3 to the 5th. Now I've done simplification only, I have not evaluated, so we're only simplifying right here. Okay, the next power that I want to talk to you about is the quotient of powers property. This is the next property. And here, again, you'll see the same bases, they're both a. A to the m over a to the n is going to equal a to the m minus n, a to the m minus n, that'll be your power. Now, whenever you have division, your denominator can never be 0. So in this case, you have to state that a cannot equal 0. So let's do a numeric example. If I have 3 to the 5th over 3 to the 2nd, I'm going to expand that out. 3 to the 5th is 3 times 3 times 3 times 3 times 3. 3 to the 2nd is 3 times 3. Well, we can see when you divide, these 3's cancel and become 1. These 2 3's cancel and become 1. You're left with 3 times 3 times 3. And 3 times 3 times 3 is 3 to the 3rd power. And again, that is just simplified. If I wanted to evaluate it, I would simply go 3 times 3 is 9, times 3 is 27. Okay, we're going on to the next set of powers. But before we do that, please note that the assignment is page 299, 12 through 34 even. If you get stuck and you've read the notes, you could always try some of the odd problems because those answers will be in the back of the book. Okay, now we're going to continue with chapter 6.1. I've grouped these powers because it's going to either be power of a something. So power of a power, power of a product, power of a quotient. And all of these have some similarities. So I'm not worried so much about you memorizing the names, but being able to look at it and understand how to identify which property you're using. So power of a power. So we have a to the m, that's a power. It's being taken to a power of n. So we're taking a power of a power. A to the m is taken to the power of n. That is going to equal a to the m times n. So I'm going to expand that to help you understand it. So here's the numeric example. 2 to the 3rd, which is a power, it's being taken to a power. So this is a power of a power. It's being taken to the 2nd power. So 2 to the 3rd is 2 times 2 times 2, and you're taking that 2 times. So here's the first 2 cubed, here's the second 2 cubed, and when you look at this in the expanded notation, you can see that you have 2 to the 6th power. Again, this has not been evaluated. That's just simplification. If I had evaluated this, it would be 81, but we're not doing that in this section. Now we're going to power of a product. So that means you're going to have a product and you're going to raise it to a power. So here's our product, a times b, and we're raising it to the power of m. When we do that, we get a to the m times b to the m. So here's two different numeric examples. 4 times 3 to the 3rd power. Yes, you could go 4 times 3 is 12 to the 3rd power. That's not what we're looking for here. When you apply the property, you get 4 to the 3rd power times 3 to the 3rd power. Again, we are not evaluating, we're only simplifying. This one's a little more typical of when you use a power of a product. So the product is 3 times a, 3a. You're taking it to the power of 4. So that would be, when you apply the property, that would be 3 to the 4th power times a to the 4th power. Much more common. We could simplify 3 to the 4th power further, but we're not. We're just applying the power of a product. Now again, these are all the power of. So now we're doing power of a quotient. Well, quotient is going to be something divided by something. Here we have A divided by B. And when you do the power of a quotient, you're taking it to a power. So A divided by B is being taken to the power of m, which is simplified as A to the m power over B to the m power. Now again, in division, whenever you have quotients, that denominator cannot be 0 or it will be undefined. So you have to state that B cannot be equal to 0. So in this numeric example, 3 over 5, that would be 3 to the 4th over 5 to the 4th power. Again, we're not simplifying, we're not evaluating this, we're just simplifying it. Here's a more common example of where you're going to use power of a quotient. Here we're just going to simplify. We've got 2 over A to the 3rd power. There's your quotient, 2 over A to the 3rd power. So that would be simplified initially 2 to the 3rd power, and then A to the 3rd power. So 2 to the 3rd over A to the 3rd. You could evaluate, you could simplify further and get 8 over A to the 3rd power, but for right now we're just showing you how these properties work. Now the last two properties don't really fit in the other categories. We had the product and quotient of powers, and then there was the power, all the power ofs. Now this one is negative exponent and zero exponent properties. In the negative exponent, what you have to remember, with the exception of scientific notation, you always write powers with positive exponents. So anytime you see something like A to the negative m power, you can't leave it like that. And the way that you fix it and get the powers to be positive is by moving it from the numerator position to the denominator, or vice versa. So A to the negative m would be 1 over A to the m. That gets rid of the negative. So 5 to the negative 2 would be 1 over 5 squared. Now again, that's just simplified first step. It's not completely evaluated. Here's another one a little bit more complicated. We've got x to the 4th over x to the negative 1. Well, you can't, this is actually going to be two properties at once, but you cannot have this negative exponent. So it's now in the denominator. I need it to move up to the numerator. So it's x to the 4th times x to the 1st because it's coming up to the numerator. And so then we've got 4 x's and 1 x, which is a total of 5 x's. So x to the 5th is the most simplified amount you can have. Now, zero exponent, not hard to remember, but doesn't make a lot of sense logically. Any base, a, to the 0 power is always going to be 1. A cannot be 0. We're not going to do 0 to the 0 power. So the only exception to this is that A cannot be 0. So any integer value, any value actually, to the 0 power is going to be 1. So here's the example I'm giving you. 100 to the 0 power equals 1. What I want you to do is, there's a second assignment. You're going to better understand this zero exponent. You're going to understand the concept of it once you've done that second graphing assignment. So really do spend the time on that, because it'll really show you why any number to the 0 power is in fact 1. Now we're going to apply all of these powers. You can always go back and reference here, or you can look at your textbook, whatever's easier. So now we're going to use all of these properties to help us either simplify or evaluate. And we're going to have to tell which powers we're using. I don't expect you to memorize which properties we're using. I don't expect you to memorize the properties, but I do expect you to know how to use them. Okay, so moving on. Okay, again, if you've been absent, you're going to want to put these on the left side of your paper. If you were here, you have them, but you might want to review them. We keep all our notes and our examples on the left side, and then we do our assignment problems on the right side. This is from page 297, the checkpoint activities for 1, 2, 3, and 4. I'm adding on a bit more than they asked for. They asked you to evaluate the expression, but I'm actually going to have you write the property you use to evaluate. So in number 5, we have 2p in parentheses to the 3rd power times p to the 4th. Okay, we are going to use initially the power of a product. Here's your product, 2 times p. We're taking it to the 3rd power. So 2 to the 3rd times p to the 3rd, and then we're just going to bring down times p to the 4th. Now we're going to use another property because we have like bases. P and p are the same base. You have 3 p's here, 4 p's here. That's a total of 7 p's. So we have 2 to the 3rd, which can be simplified to 8. 2 times 2 times 2 is 8, not 6. And then p to the 7th. That is as simplified as it can get. we go, oops, my apologies, I did those out of order. This is checkpoint 297, this is number 1. So you've heard 5, now we're going back to 1, sorry about that. So 2 to the 4th power, that is going to be 2 to the 4th is a power. You're taking it to the 3rd power, so it's a power of a power. So we have 2 to the 4th 3 times. So 2 to the 4th is 2 times 2 times 2 times 2, but you have that 3 times. So there's 4 2's, then another 4 2's, then another 4 2's, which is a total of 12 2's. So you have 2 to the 12th power. You definitely want a calculator for this. You put that in. 2 to the 12th power is 4,096. That has been evaluated because you have a single number when you were finished. Okay, number 2, 5 to the 0 power. Anything to the 0 power is 1. That is the 0 exponent property you're using. Number 3, negative 3 in parentheses. That's important. Keep it in parentheses to the 2nd power times negative 3 to the negative 7 power. Now, number 3 could be evaluated in a couple of different ways, but I'm going to start with this negative exponent because right now it's in the numerator. I can't have this negative 7. I'm going to bring it down to the denominator, so negative 3 in parentheses, but instead of being to the negative 7 power now, it's going to be to the 7th power because I moved it from numerator to denominator. So I have negative 3 in both of these, a same base. So I started with the negative exponent property, got rid of the negative exponent, made it positive. Now I'm doing the quotient, it's division, of powers. They have the same base. So this negative 3, there's 2 of them in the numerator. This negative 3, there's 7 in the denominator. So I'm going to stretch it out or expand it for you. So we've got negative 3 times negative 3 in the numerator. And then we have negative 3 being multiplied together 7 times in the denominator. These 2 negative 3's become 1. These 2 negative 3's, when you divide them, also become 1. So 1 times 1 is your numerator amount. It equals 1. And then your denominator, you're left with 1, 2, 3, 4, 5 in the denominator, the negative 3, so negative 3 to the 5th. And then if you plug this into your calculator, negative 3 raised to the 5th power is going to be negative 243. So we rewrite it as negative 1 over 243. Okay, number 4. We've got 2 7ths. That is division. Okay, that's a quotient. And you're taking it to a power, so it's power of a quotient. So that's going to be 2 to the 3rd over 7 to the 3rd. 2 to the 3rd is 8. 7 to the 3rd. 7 times 7 is 49. Times 7 is 343. That's as simplified as it gets. Now we're going to move on to 5 through 8, but as you know, I already did 5, so I'm going to start on 6. Okay, number 6, we have x to the 5th, y to the 3rd over x times y to the negative 4th. I'm going to get rid of the negative exponent first. That y to the negative 4th, bring it up to the numerator, so it's x to the 5th times y to the 3rd times y to the 4th, just stretching out a little with the time signs. This x in the denominator was just fine, so bring it down as x. Now I've got some matching y bases, so I'm going to use the product. Y to the 3rd times y to the 4th is multiplication, so the product of powers, they have the same base. 3y's and 4 more y's is 7y's. So x to the 5th times y to the 7th over x. Now I've got x's in the numerator and denominator, so I'm going to use the quotient of powers. I have 5 x's in the numerator, 1 in the denominator. I'm left with 4 x's after I cancel in the numerator, x to the 4th, y to the 7th. All right, number 7 is 3b to the negative 2 in parentheses. So that is going to be a product, 3 times b to the negative 2. And that's raised to the 3rd power, so it's power of a product, b to the 8th. We're going to use power of a product first. I'm not going to deal with the negative exponent until second. You'll see why in a minute. So 3 to the 3rd power times b to the negative 6. Negative 2 and 3 is negative 6 power times b to the 8th. Now I'm going to apply the negative exponent property. I'm going to move the b to the 6 to the denominator. 3 to the 3rd is 27. b to the 8th is just fine. Leave it in the numerator. So I have 8 b's in the numerator, 6 b's in the denominator, and now I'm going to use the quotient of powers because you have matching bases, b and b. you have two b's left in the numerator, so it's 27b to the second power after you cancel using the quotient of powers. Your assignment is page 299, 12 through 34.